Today, we are putting together a brand new visual toolkit for your brain. We're going to break down how logical arguments are built piece by piece so you can actually see them.
I know, it sounds a little weird, right? But what if you could visualize the claims people make every day? Map them out so they make perfect sense. Well, you can. And the secret is a surprisingly simple tool called a Venn diagram. By the end of this, you'll be an expert.
So here's our game plan. We'll start with the absolute basics, the building blocks. Then we'll see how they connect. After that, we'll get into the four main blueprints for any logical claim, practice translating regular speech, and wrap it all up with a quick review. Let's get to it.
Okay, let's start at the very beginning. Before we can get into the complicated stuff, we need to understand the one simple idea that everything else rests on.
And that idea is the set. It's really just a formal word for a group of things. Like the set of planets in our solar system, and its members are Mercury, Venus, Earth, and so on. Simple, right? This is our fundamental unit of thought.
So how do we picture these sets in our mind? Well, we use a brilliant invention from a logician named John Venn. His diagrams use overlapping circles to show us exactly how different ideas relate to each other. It's an incredibly intuitive way to see logic in action.
All right, now that we have our building blocks, sets, and our main tool, Venn diagrams, let's look at the only three ways any two sets can possibly interact. That's it, just three.
And this slide shows them all perfectly. First, one set can be a subset, which means it's totally contained inside the other one. Second, they can be disjoint, completely separate, sharing nothing. And third, they can be overlapping, meaning they have at least a few members in common. And here's a fantastic real-world example of subsets. Look at this. The natural numbers, 1, 2, 3, are completely inside the set of whole numbers, which just adds 0. And that set is completely inside the integers, which adds the negative numbers. It's like a set of Russian nesting dolls, and the diagram makes that structure obvious.
Okay, let's get to the main event. Here's the thing. Pretty much any claim you can make that relates to groups of things can be boiled down to one of just 4 basic types. Think of them as the 4 blueprints for logical statements.
Now, in all of these blueprints, we've got 2 main characters. The subject set, we'll just call it S, is the thing we're actually talking about. And the predicate set, or P, is the group we're relating that subject to. Let's see how they work.
So, form number 1 is the big universal claim. All S are P. A classic example is all whales are mammals. When you draw this, it's a simple subset. The whole circle for the subject, whales, is tucked completely inside the circle for the predicate, mammals. Every single one.
Form 2 is also universal, but it's a universal no. No SRP. Like no fish are mammals. The Venn diagram for this one is super clear. The S circle for fish and the P circle for mammals are totally separate. They're disjoint. They don't touch at all. Okay, now we move to claims about some things, not all things. Form 3 is some SRP. For example, some doctors are women. Now look closely at the diagram. The circles overlap, sure, but that just shows it's possible. The X is the most important part. That X is like planting a flag. It asserts that, yes, there is at least one real person who is both a doctor and a woman. And our last one, Form 4, some S are not P. An example could be some teachers are not men, and just like before, that X is key. It asserts existence. But this time, we put the X inside the subject circle, teachers, but clearly outside the predicate circle, men. That X represents at least one actual teacher who is not a man.
All right, now for what might be the most useful part. See, people rarely talk in perfect, clean logic. To really use this toolkit, you have to learn how to be a translator. The way we talk in real life is, well, it's messy. It's full of shortcuts and assumptions. But logic needs to be precise. So the absolute first step before you can analyze what someone is saying is to rephrase it into one of those 4 standard forms you just learned. This forces you to be totally clear about your subject and your predicate.
Let's try one. Take the sentence, some birds can fly. To put this into a standard form, we need a clear subject and a clear predicate. The subject, S, is easy, birds. But the predicate, P, we can't just say can fly. We need a noun, a group of things. So we rewrite it as animals that can fly. And boom, now it's a perfect some SRP. All right, your turn. How about this common saying? Elephants never forget. How would you translate that into one of our 4 forms? Think about what claim it's really making.
What are the two groups here? And the answer is no elephants are creatures that forget. See, the statement is a universal denial. It's saying there's absolutely no overlap between the set of elephants, our subject, and the set of creatures that forget, which is our predicate. It's a perfect no SRP statement.
We have covered a lot of ground, from what a set is all the way to translating everyday speech. So now, let's pull it all together into a final, super handy study guide. And here you have it, the whole toolkit on one slide. This is your cheat sheet. For each of the 4 forms, you've got its structure, a clear example, and the rule for drawing it. Just remember, the universal claims, all and no, are about how the circles themselves relate. Are they nested or separate? But the particular claims, the sum statements, are always about existence. That's why they need that little X to show that something is really there. We started this by asking a simple question. How can you see an argument? And now you can. You have a method for cutting through messy language and seeing the clear logical skeleton underneath. So the next time you hear an argument, a debate, or even a simple commercial, you have the tools to map it out. The only question left is, what are you going to see differently now?